Hello everyone, this is Mrs. Fitch, and I'm here today to give you guys a little tutorial lesson on factoring and solving quadratics, part 1. I've split it into two parts. This first part is going to be on factoring quadratics, and then I'll make a part 2, which will actually be just talking about solving the quadratics. But in order to be able to solve quadratics, we need to know how to factor quadratics. So in this lesson, we're going to talk about what does factoring mean, and then we're going to go through a couple examples of how to actually factor these quadratics. So we'll get these problems, and it'll tell us to factor completely. And what does that actually mean? Well, if we think of the word factor, and we go back to our whole number mathematics, if you think of the number 6 and we wanted to find the factors of 6, factors are the numbers that we multiply by to get the original number. So if we want to figure out the factors of 6, what is it we multiply by to get 6? So for example, 2 and 3 would be a factor of 6. So we use that same concept when it comes to factoring these quadratics. We're looking for what is it, or what numbers do we multiply by in order to get this quadratic. And we know this is a quadratic because if we look at our highest exponent is going to be a 2. So when I look at this quadratic, I see that it's in standard form. And there's a few different forms of when it comes to writing in quadratics. But our standard form is ax squared plus bx plus c. And I apologize for my penmanship. I need a pen to come in the mail to write on this little iPad a little bit more clear. Give me a couple lessons and it should be here within a week, so hopefully my penmanship will get better, but no guarantees. So, anywho, so our quadratic is in the standard form. So when it comes to factoring these, we want to make sure that we can find our a, our b, and our c. So if I actually take our original quadratic and I write it underneath, so I have my x squared minus 2x minus 8. Hopefully it'll make us, it helps to clarify which one is a, b, and c. In mathematics, sometimes when we multiply by 1, we never put that in our problems. So technically when we're looking at our x squared value here, there's technically a number right there. And sometimes we don't write it. And the only time we don't write it is when it's a 1. So sometimes if it's helpful for you, go ahead and write that 1 in the problem if it helps. And then from here we can tell that our a is going to equal 1, our b equals negative 2, and our c equals negative 8. So to start the process of being able to figure out what those factors are, what it is that we multiply by in order to get this quadratic, there's a couple different methods I guess you could use in order to factor. Some people there's a FOIL factor, some people call it an Xbox factor, some people call it completing the square, some people call it an area model. There's a couple different ways of kind of going through these problems, and usually through examples and practice, you kind of figure out which one you're more comfortable with. So we're going to kind of do one that has to do with our little x. So we're going to make an x, and then on the top of our x is always going to be our a times our c value, and b for the bottom, b is going to go on the bottom. So when we look at our problem that we had, we figured out that our a was 1 and our c was negative 8. So we can plug that in. So a was 1 times our c, which is negative 8, which is going to give us negative 8. Right? And our b was negative 2. So we can put negative 2 on the bottom. So now we need to figure out what values are going to go onto either side of our x. So ultimately, we have to multiply numbers together in order to get negative 8. And when we put the sum or add those two numbers together, we need to get -2. So we need to figure out our factors, what we multiply by, in order to get -8. But to start with, I always look at the sign. So I have a -8. So I want to figure out what sign these two numbers have to be. So I need to figure out what kind of numbers I multiply by to get a negative. I could either have a positive and a positive, a negative and a negative, or a positive and a negative. And in order to get a negative number, I know one of them has to be positive and the other has to be negative. Now I'm going to figure out my factors to get 8. So I either have 1 times 8. Again, I apologize for my handwriting. It'll get better, I hope. So if I sit there and if I put a negative on either one of those, I know that I can either do a -1 plus a +8. That's not going to get me to -2. Or if I put the negative on the 8 and a +1, either way, I'm not going to get to a -2. So I know that these factors are not going to work. So my other choice would be 2 times 4. So if I use 2 and 4 to try and get to a -8, can I put a negative on one of those to where when I add them together I get a -2? And I can, right? If I have a -4 and a +2, when I add these together I get -2. So you always can stop right here and double check yourself, because we know that 2 times -4 has to give us -8. And 2 minus 4 has to give us -2. So now that we know that our x is correct, we can kind of move on to the next step. Ultimately, our goal, remember, was to figure out what it is that we have to what we are multiplying by in order to get this quadratic. So we almost got to split this up somehow. So that's ultimately what we're doing here. This is helping us split this middle term. So really, I'm going to throw some x's on here because I want this to be that middle term. All right, 2x minus 4x is going to give me -2x. So now I'm going to go back to this original quadratic and I want to rewrite it, but instead of writing it with that -2x in the middle, I'm going to rewrite it with these two new factors. So I'm going to rewrite that original equation, or sorry, that original expression, quadratic, as x squared plus 2x minus 4x minus 8. And if I simplified this by combining those like terms, I would be right back to that original quadratic. So I've not changed the problem at all. I've just written it differently. So now I can sit there and I can look at my little quadratic, and now I'm gonna split my factors. So if I look at these two factors, I'm gonna look to see if there's a common factor that they have that I can factor out. And between x squared and 2x, I know that I can take out an x, and then I'm left with x plus 2. I'm going to do the same thing with these two terms. Do they have something in common? Yeah, they have the common factor of -4. So I'm going to factor out a -4, and I'm left with x plus 2. And if you need to, you can double check yourself just using the distributive property, right? X times x is x squared. X times 2 is 2x. -4 times x is -4x. -4 times 2 is -8. So now I'm just going to keep going through this whole factoring process. Do I have a factor in common? Absolutely. I got x plus 2 and x plus 2. And that's what I want. I want to find a common factor that I can still factor out. So now I can factor out my x plus 2. And what am I left with? X minus 4. Right? Now I have my two factors that I am technically multiplying by, right? Or my two terms. So these are my two numbers that I'm multiplying by to get my original quadratic. So there are my factors. So let's spice it up a little bit. Let's say we had 7x squared plus 9x plus 2. So we're going to use that same exact process that we used on the original problem. If we need to, let's write down our a, b, and c. Our a is going to equal 7, our b is going to equal 9, and our c is going to equal 2. So start by making our x. We know that on top we got a times c, and on the bottom is b, right? My a is 7 times my c, which is 2, and b in the bottom is 9. Oops, and what's 7 times 2? What was it? Yeah, 14. Good job, guys. So again, I'm going to look at the sign. So I got a positive 14. So I have to figure out what kind of numbers I can multiply by to get a positive 14. I can either do a positive positive or a negative and negative. And this guy down here, because he's positive, that is ultimately going to tell me that I'm going to have a positive and a positive. I'm going to go through my factors of 14 to sit there and figure out what it is I can do to get to 9, right? So I got what? 1 times 14. There's no way I can combine those two to get 9, so we know that one's not going to work. So what's my next option? 2 times 7. 2 times 7 is going to give me 14, and when I add those together I get 9. So I know I got a 2 and I got a 7. And I know these are x, right? Because I want this to be that representation of my 9x. So now we're going to rewrite that original quadratic, right? But instead of writing it with 3 terms, we are ultimately going to be writing it with 4 terms. Because instead of 9x, we're going to write 2x and 7x. So what do we got? 7x squared plus 2x plus 7x plus 2, right? Oops. So now I'm going to put these first 2 terms together, and then I'm going to see between 7x squared and 2x if there's a common factor that they have. When I look at 7 and 2, there's not a common factor that I can pull out, but I do have an x squared and an x, so I'm going to actually factor out an x. And when I pull that x out, what am I left with? 7x plus 2. Now I'm going to do the same thing down here. When I look at these two, I'm looking for a common factor. I'm going to look at my 7 and my 2, and then I'm going to look at my x. And it really doesn't have any number that I can pull out, but you can always find a common factor. We can always find a commonality in anything in life, right? And we can do the same thing with numbers. When we look at these, the one thing that they will always have in common is going to be a 1. So technically I can pull out a positive 1. And when I pull out a 1, it's not going to change anything, right? Because 1 times 7x plus 2 is 7x plus 2. So when I factor out that 1, I'm still left with 7x plus 2. So now I'm going to look at my problem, and I want to hopefully find a common factor. And I do, my 7x plus 2 and my 7x plus 2. So now that I have that common factor, I can factor it out of the entire quadratic. So I have 7x plus 2. And then what am I left with? My x plus 1. X plus 1. So now, by definition of factors, it are numbers that are being multiplied by to get the original equation. And that's exactly where we are. Alright, one last one. I know I'm running a little long. So we really spiced it up and gave you guys a nice little problem. So the first thing always when it comes to the quadratic is I always look to sit there and see if there's a common factor that I can pull out. And when I look, I have a 5, and that 150, I know I can factor out a 5. So the first thing I'm going to do, I'm going to factor out the 5, and I'm left with x squared plus 5x. Sorry, I apologize. I do not. When I factor out the 5, I have 5 times x squared plus x minus 30. Now, other than the 5 being in the front, this looks just like that very first problem we did with just some different numbers on it. So it's the same exact process. We just ultimately can't forget about our 5. Nobody wants to get forgotten about, and we definitely don't want to forget about our 5. So we're going to go through that process of sitting there and trying to figure out how to factor this. So we're going to start by making our x, right? A times c on top, b on the bottom. So we're only factoring this part of our quadratic, right? So when it comes to our a is that number up front, which is technically now a 1, and our c is negative 30. So 1 times negative 30 is going to give us negative 30, and our b, that number in front of x, is going to be 1. So I'm looking for numbers that when I multiply them by, I'm going to get a negative. So the only way I can get a negative number is if 1 is positive and 1 is negative. Now I need to figure out what factors, or when I multiply, I get 30, but when I add them together, I get 1. So we can either run through them real quick, right? 1 times 30, ooh, there's no way I'm going to get a 1. 2 times 15, there's no way I'm going to get a 1. 3 times 10, oops, see, this pen. There's no way I'm going to get to a 1. What about 5 times 6? I can definitely get to a 1 off of 5 and 6, right? So I need to get to a positive 1, so I know that my 6 is going to be positive and my 5 is going to be the negative, right? And we know to add our x's on here, because ultimately this is our middle term. Oops. Right there, right? 6x minus 5x is going to give us that 1x. So now we can rewrite our original equation, or sorry, not equation, expression, our original quadratic expression. We can rewrite that, right? Don't forget our 5. So we still have our 5. And then now we have x squared plus 6x minus 5x minus 30. And then just like before, we're going to sit there and look at this part of the quadratic, and we're going to split it and see if we can find those common factors. So I'm going to split it by looking at these first two, and on those first two I'm going to factor out an x, and then I'm going to be left with x plus 6. And then I'm going to look at these two terms, and I'm going to factor out a negative 5, and I'm left with an x plus 6. Hopefully I have factors, a common factor that I can factor out, and I do, which is going to be my x plus 6. And then what am I left with? That x minus 5. And I'm almost done. I just have to make sure I don't forget about this 5. So all we're going to do with him is we're just going to drop him down, put him out front. And now I have my factors. Right? Sorry I ended up being a little bit longer video than I thought it was, but hopefully you guys find it helpful. The next video, the part 2 on this one, will be using the same method, but then we're going to actually solve our quadratics. So look forward to those equal signs that we finally get to see with. I'll talk to you soon. Bye.